Firstly, I'll start out by explaining how to do three variable systems. And you're going to want to get rid of a variable first. And since we have z isolated already, what we're going to do is we're going to negative 2 by z to counteract or cancel out negative 2z on the bottom, because two negatives equals a positive. Now, once you have what you're going to do, you're going to want to do the rainbow method and multiply negative 2 by every number in the equation. Now, you'll take this new equation and combine it with the old equation, which would be negative 5x plus 6y negative 2z. And now we're going to end up with x plus 24y equals 9, and we'll use that equation later, but for right now, let's just save it to the side. Now we're going to use our other equation we haven't used yet, which is negative 4x, negative 4y, negative 9z equals negative 9. And we're going to use that with negative 3x, negative 9y, negative z equals negative 24. And it doesn't have to be this equation that I'm using it with, but this just feels the most easy to me, so I will use it with this one. Now we should end up with 27x plus 81y plus 9z equals 216. And the numbers do look a little high, but don't worry, they will get lower. And now, of course, we're going to combine the old equation with the new equation. And now this should get us 23x plus 77 equals 207. And I know the number is really high. Don't be scared. It will get lower. And now what we're going to do is we're going to take these two new equations that we have, and we're going to basically use elimination on them. Now what we're going to do with our new information of y equals 0, we're going to make y 0. We're going to substitute it in for y, and we should get x equals 9. And now with both these numbers, we're also going to do the same thing for z. Also note, you are substituting both x and y. So you will be using 9 as x and y as 0. Now for the word problem, we're going to want to find the key things in this word problem. So first, we're going to read it out. A teacher is setting up chairs and tables in a classroom. She notices 3 tables and 2 chairs have a total of 22 legs. In another side of the room, 5 tables and 2 chairs have a total of 30 legs. How many chairs does 1 chair and 1 table have? So first, to start it out, you're going to want to highlight or underline the most important factors in this question. And now we're going to want to figure out what our variables are, which would be t and c in this case. Now that you have what you need, you're going to want to make your equation. In which we will solve for elimination. So we're going to first do negative 1 because we need to cancel out the c. Since we already have negative 2 on both c, we could just use negative 1. In which we'll end up with negative 2t and equals, it should equal I think it's 8, but I miswrote and I wrote 30, so just wait for me to fix it. And then of course from here you're just gonna want to divide it with the c, because you're not trying to cancel out the t, you're just trying to get rid of the number that's in front of it, or the coefficient. in which you have t equals 4, if I'm not mistaken. And then now here, you're just going to substitute it for the t, and then you should end up with this, which we will now do two-step equation, and negative 12 on it. So you're going to do negative 12 by the equal whatever it was, and then 2c equals 10. You're obviously going to divide to get rid of the coefficient, which should end up with c equals 5. With this created word problem, it's not meant to like represent real life tables and chairs. It's just for example, of course. Obviously there's not 5 legs on a chair, but you know, it is what it is. Okay, now for the best part of this is graphing. What we're gonna do here is we're gonna first isolate the y to be y is greater than however much it is, and first we're gonna start out with negative 4x, negative 4y is greater than 24, and then what we're gonna do is positive 4 on each side. I miswrite things a lot, so my mistake if I miswrite something. Net positive 4x on each side, and then now we're gonna have negative 4y is greater than 24 plus 4x. And now what we're gonna do to isolate the y, we're gonna divide by the coefficient, so negative 4, and divide by negative 4 by everything, so on the left and the right side. And then we should finish off with y equals negative x negative 6. Oh wait, I'm sorry. Is greater than negative x negative 6. We'll fix that in a bit. I just realized that now. And also remember, x is our slope, and we're gonna obviously always follow the rule rise over run, which means the number above is the rise or the y, and the below is the x. So negative would be obviously going left, positive going right. With rise, it'd be positive going up, negative going down, you know, the usual. And then now what you did with the last equation, you just do the same thing for this next one. So now that you have both your equations, you're going to want to graph them. And I'll do that now. So that now that we have both our equations, now we're gonna look look at the symbols, and as you notice, one of our equations has the line under, which means it is a solid line, and one of doesn't. So that means the one that doesn't will be a dotted line, or more of like, I don't know how to explain it, but a dotted line, we'll say. Also, this is what you noticed. It is a equal sign at the top, and I'll just fix that now. And since it is has no line on the bottom, it means it is a dotted line. I'm gonna change that now too. Now looking at the graph on the bottom, you'll notice that everything at the top means that we shaded everything at the top. So of course you're going to do that. Everything above the line will be shaded. Nothing below should. And it's the same for both sides. And do now do the same thing with the other line too. And now wherever you notice the colors will begin to mix together, that is all possible solutions. So everything that is every coordinate that is mixed together, those are all every possible solution that is correct. Anything that isn't shaded is not, obviously. So, and everything that is only shaded by one color also is not. So everything that is shaded by both colors is a possible solution.